Talk about these questions. So, a bullet of mass 146 grams and velocity of 131 meter per second goes through one stationary block of mass 1.9 kilogram. Then gets stuck in a second stationary block of mass 1.6 kilogram. The first box is moving. The first box is moving with 1.1 meter per second after collision. So, how fast is the second box moving after the collision? Okay. So the situation is like this. This is how the bullet is traveling at 131 meter per second, and this is 146 grams. And there was first box over here that was stationary, and that was a 1.9 kilogram. So after the collision, this block started moving at 1.1 meter per second, and the bullet started moving with some velocity v, which we do not know. After bullet keeps on going and then collides with a second block of mass 1.6 kilogram. And the bullet embeds into it, right? The bullet embeds into this big block, and they both now start moving as a single unit with some velocity v dash. So what do we have to find? We need to find out how fast is the second block moving after the collision. We need to find the value of v dash when definitely these two add up, because 146 grams is 0.146 kilograms, right? And when we add up these two, we get 1.746 kilograms. So because 1.6 plus 0.146 is 1.746 kilograms. We need to find the value of v dash. So we need to apply the conservation of momentum in two cases, case A and case B. Let's apply the same in case A. So the initial momentum is going to be only because of the bullet, because this is anyway at rest. So only because of the bullet, that's going to be mass times velocity. So what is the mass? That's 0.146, because that's got to be converted into kilograms by dividing by 1000 times the velocity, which is 131. And that should be equal to the final momentum. So final momentum is got to be mass times velocity of this one. So that's got to be 1.9 times 1.1 plus the momentum of this one, which is again going to be 0.146 times v. Okay, let me just grab my calculator. So 0.146 times 131 gives us 19.126. 1.9 times 1.1 gives us 2.09, and this will be coming as 0.146 V. So 19.126 minus 2.09 comes out as 17.036, and that is equal to 0.146 V. So 17.036 over 0.146 gives us the value of V as, so basically I've just divided both sides by 0.146. So the value of V which I'm getting as is 116.68 meter per second. Okay. Now I'm going to conserve the momentum. This was the momentum conservation in A. Now I'm going to conserve the momentum in B. So what is the initial momentum in this case? That's going to be 0.146 times V, which is 116.68, which we just found. And this is of course at rest. And the final momentum is going to be only because of this, because they becomes one unit. So 1.746 times V dash. So the value of V dash from here comes out as 0.146 times 116.68, which is the velocity of the bullet after colliding, after passing through the first block, over 1.746, that is equal to V dash. So the value of V dash from here comes out as, that's what we have to find, times 0.146 over 1.746. So this value comes out as 9.76 meter per second up to 2 decimal places. Let's talk about question number 11. So two objects of mass 2.1 and 2.6 kilogram move with velocities 2 comma negative 3.2 and negative 2.8 comma 1.4, which means that these are the x and y components of the velocity. The two objects collide and stick together. Find the x and y components of their common final velocity and the magnitude, as in the length of the final velocity, um, as in the magnitude and the length of the final velocity in meter per second into the answer box. Find the x and y components of their common final velocity and enter the magnitude of their final velocity. Okay. So of course we are going to conserve the momentum in both the directions. So for the first for the x direction, this is 2.9 kilogram having the velocity of 2.2 meter per second, and 2.6 kilogram having a velocity of negative 2.8 meter per second. And after the collision, they become one unit, right? So what is 2.9 plus 2.6? That's going to be 5.5. So after that, 5.5 kilogram is moving with some velocity v. So if we conserve the momentum, then initial momentum is 2.9 times 2.2 plus 2.6 times minus 2.8. That's going to be equal to 5.5 times v. So we're on the left side, that becomes 2.9 times 2.2 minus 2.6 times 2.8 over 5.5. So the value of V from here comes out as negative 0.16 meter per second. Right. So this is the velocity towards the x direction. Then let's talk about the y direction. So I'm going to say that this is towards the x direction. So for the y direction, again, we are going to conserve the momentum. So individual velocities are negative 3.2 and 1.4, negative 3.2 and 1.4. And what are the masses? What are the mass? That's 2.9 kilogram and 2.6 kilograms. So if you conserve the momentum, that's going to be 2.9 times minus 3.2 plus 2.6 times 1.4. That's going to be equal to 5.5 times some velocity v2. So the left side becomes 2.9 times 3.2 minus 3.2 minus 2.6 times 1.4. So that's going to be minus 5.64. That is equal to 5.5 v2. So dividing both sides by 5.5, we get the value of v2 as minus 1.03 meter per second. And all we have to do is club these two up and give the final answer only as a magnitude. So we know that v1 is towards the minus x-axis like this, and v2 is towards the minus y-axis is like this. So their net resultant is going to be square root of first one square plus the second one's square. So that's going to be 1.03 whole square plus 0.16 square, and the square root of this value comes out as 1.03 only, 1.04 in fact meter per second. That is the final magnitude of their net velocity. And these are the x component and the y component.